Good morning, dear students. A warm welcome to all of you for our today's digital session for the subject Science and Technology Section A. In our previous session, we have started with a new chapter from Section A, chapter number 7, Lenses. In this chapter, we have seen the two types of lenses, that is concave and convex lenses, and the different terms related to them. Also, we have studied about the images which are formed by concave and convex lenses and the different rules which have to be followed while drawing the ray diagrams. The topics which we are going to cover today is a very important, interesting topic, a part of your body, that is human eye. The different parts of the human eye, the different defects which are faced by the human eye, how these defects can be corrected, and we are also going to study about the uses of concave and convex lenses. Before we start with the topic of human eye, I would just within the first 5 minutes like to cover the small part which is remaining from the first part of the chapter, that is the sign conventions, lens formula and the power of a lens. So let us start with the sign conventions. Last year in chapter number 11 of section A, you have studied the sign convention for mirrors. According to the Cartesian sign convention, in the case of mirror, the pole of the mirror was taken as the origin. In the case of lenses, the optical center, you all know what is optical center. Yesterday you have, in the last session, you have studied about it. Optical center here is taken as the origin. The principal axis is the x-axis of the frame of reference. Now the sign conventions are more or less similar to the sign conventions which you have studied last year. The first is the object is always placed on the left of the lens. This is the left part of the lens. The object is always placed on the left of the lens. Hence, all the distances parallel to the principal axis, they are measured from the optical center. The next sign convention says the distance which is measured to the right of optical center, they are taken to be positive, while those to the left are taken as negative. Third sign convention says the distances perpendicular to the principal axis and above it are taken to be positive. Perpendicular and above the principal axis, they are taken to be positive. Distances perpendicular and below the principal axis are taken to be negative. And last is about the focal length. The focal length of a convex lens is positive, while that of a concave lens is negative. Now this part you have to remember carefully, because when we speak about the human eye, there are different defects, and in that defects you have to see what focal length of a convex lens is, what focal length of a concave lens is, and then accordingly you have to decide the spectacles. Also in numerical examples this will be very useful. Focal length, if it is given in the question, if it is a convex lens, while writing the value in given, you will take it as positive. If it is a concave lens, even if the value is positive, while writing you will take it as negative. Next topic is magnification produced by a lens. Magnification, last year also you have studied. Lens formula, last year you have studied the mirror formula, which says that u was the distance of the object, v was the distance of the image, and f was the focal length. Similarly here, 1 upon v minus 1 upon u is equal to 1 upon f. This is the lens formula. Magnification due to the lens is nothing but the ratio. You can see here it is the ratio of the height of the image to the height of the object. So height of the image is h2, height of the object is h1. So magnification capital M is equal to h2 upon h1, or it is also v upon u, that is the distance of the image to the distance of the object. Last year also magnification produced by the mirror you have studied. Next is power of a lens. There is the capacity of every lens to either converge or diverge the incident rays, to either bring together or to spread apart the incident rays. That is called the power of the lens. The capacity of a lens to converge or diverge incident rays is called its power, denoted by capital P. Formula is capital P power is equal to 1 upon focal length in meter. For 1 diopter power, it is 1 upon 1 meter. Combination of lenses. If you take two lenses with focal lengths f1 and f2 and they are kept in contact with each other, then the combination has an effective focal length which is given by 1 upon f is equal to 1 upon f1 plus 1 upon f2. So all the formulae which you have studied here, 1 upon v minus 1 upon u is equal to 1 upon f. Let us go to the previous slides. 1 upon v minus 1 upon u is equal to 1 upon f. M is equal to h2 upon h1, also v upon u. P is equal to 1 upon f and 1 upon f is equal to 1 upon f1 plus 1 upon f2. Remember all this because you are going to apply it while solving the numerical examples. Now we come to our interesting topic, that is human eye. Last year in 9th standard, you have studied about the parts of the human ear. The human ear was divided in 3 parts: inner ear, outer ear, middle ear. Similarly, now we are going to see each and every part of the human eye. So let us see with the help of a diagram. The first part which you can touch with the help of your fingers is the cornea. This is the figure of a human eye. You can see the first part, the outer part of the eye. The thin transparent cover membrane on the human eye is called the cornea. Light from the environment, it enters the eye through it. Last year you have studied the outer part of the ear or the pinna, which you can touch. The main function is to collect the sound waves from the environment. Similarly, ear function is the outermost thin layer. If you touch it also, it is very delicate. Maximum amount of incident light is refracted inside the eye at the outer surface of the cornea. You can see it is a thin transparent membrane, so refraction of light takes place where here at the cornea, because light is entering from one medium into the other medium. The next part which you come across after the cornea is the iris. Now the dark fleshy screen right behind the cornea, which you can see here bluish color, that is known as iris. Now the color of the iris is different for different people. This is the peculiarity, this is the unique character of iris, and we have heard about people saying you have cat eyes or the color of your eyes is brown. So today you have come to know that it is the role of the iris which gives a specific color to each eye. After iris, we come across the third important part of the eye, that is the pupil. Here you can see this is a small hole of changing diameter. You have studied in geometry radius and diameter, which is at the center of this iris. You can see this is the cornea. After the cornea there is iris, and the center of the iris is known as the pupil, which controls the amount of light entering the eye. So a very important role is played by this pupil. The pupil controls the amount of light entering the eye, and in this way if the light falling on the eye is too bright, then the pupil will contract, while if the light is dim, it widens. And this effect is experienced by you in different daily activities. During the night time, suppose the atmosphere is very dark, it is too means there is no light around you, then if you want to see something, you widen your eyes. Or at the same time, some vehicle is coming in that dark right in front of you, and the light from the vehicle, it falls on your eyes, the light from the headlight, then immediately you close your eyes. So this is the, you can say, reaction which is brought about by the pupil. So major role is played by it. Next is the lens, the very important part of the human eye. What is the function of this lens and where it is? On the surface of the iris, this is the iris. On its surface, there is a bulge of transparent layers. This is the bulge of transparent layer. There is a double convex transparent crystalline lens. You can see here. This is the lens which is being held by the ciliary muscles. So it is a double convex transparent crystalline lens, and the main function is this lens. You can see just behind the pupil. The main is to provide small adjustments of focal length to focus the image, and this is the lens which creates real and inverted image of an object which you see. That real and inverted image of the object is projected on the screen inside the eye, which is the next part of the eye which we are going to study. The next part of the eye is the retina. I have told you just now that the real and inverted image is formed by the lens on the screen, which is the retina. How when you visit a theater, you see the film on the screen. Similarly is the role of retina. Now this light sensitive screen, this retina, it is made up of light sensitive cells, and this screen is called as retina. These cells, they get excited when the light falls on them and generate electrical signals. The signals are conveyed to the brain through the optic nerve. In the human ear, last year you have studied about the auditory nerve, the cochlea, the snail-like structure which converts the sound, the vibrations into electrical signals and are conveyed to the brain. Similarly here, these cells, they generate these electrical signals and they are conveyed to the brain through the optic nerve. Later, what does the brain do? The brain analyzes the signals and converts them in such a way that we perceive the objects as they actually are. We can see the objects as they actually are. Next, we will see how the focal length increases or decreases. So while you see the objects at large infinite distances, the lens of the eye becomes flat and its focal length increases. See here, when you are seeing the objects which are at infinite large distance from you, then the lens has become flat. Exactly opposite, while seeing nearby objects, the lens becomes more rounded and the focal length decreases. This capacity of the lens to adjust, to change its focal length as per the need is called the power of accommodation. A very important definition. The capacity of the lens, you have studied about the lens, to change its focal length as per the need. Means if you have to visualize large distance, if you have to objects which are at large distance, or if you want to see the objects which are at nearby distance, then that lens has to change the focal length, and that property, that capacity is known as power of accommodation. The minimum distance of an object from a normal eye at which it is clearly visible without stress on the eye, that is called as minimum distance of distinct vision, and for the normal human eye it is 25 centimeter. The position of the object at this distance is called the near point of the eye, and for a normal human eye the near point is at 25 centimeter. This you can just experience by doing a small activity. If you take a book, you start reading a book and then try to bring the book very near to your eyes. When a distance less than 25 centimeter is achieved, the alphabets, the things, the pictures start getting blurred. So the minimum distance at which an object should be held so that it can be clearly seen by the human eye without any strain on it is 25 centimeter, which is known as the minimum distance of distinct vision. The farthest distance of an object from an human eye at which it is clearly visible without stress is called the farthest distance, and the position of the object at this distance is called the far point, and for a normal human eye the far point is at infinity. So this you have to remember. Now the very important topic and maximum questions expected in the board exam on that particular topic is the defects of vision and their corrections. How these defects are caused? Some people, they cannot see the things clearly due to loss of accommodation power of the lenses in their eyes. So the strength, the capacity of your eyes to see the objects very clearly, it depends on this part, power of accommodation. Because of the defective refraction by the lenses, now lens is a crystalline, transparent thing. So because of the defective refraction by the lenses, their vision becomes faint and fuzzy. And 3 types of refraction defects are there, which we are going to study in the syllabus. The first one is nearsightedness or myopia. Now here it is defects of vision and their corrections. These defects cannot be cured, but they can be corrected. Nearsightedness or myopia. Look at the word. This word itself tells you that in this defect, the person is able to see nearby objects, nearsightedness. So in myopia, the eye can see nearby objects clearly, but the far away or distant objects, they appear indistinct. They cannot be seen clearly. These people are not blind. So you cannot say that the far away objects cannot be seen at all. But the far away objects cannot be seen very clearly. So what you can say over here, the far point of the eye is not at infinity but shifts closer to the eye. So in nearsightedness, you can see that the image of the object, here it is the retina. Nearby objects can be seen because the image is formed on the retina, whereas for the myopic eye, the image of the far away object, it is formed in front of the retina. For a person to see any object, the image of that should be formed on the retina. Here you can see that the image of a distant object forms in front of the retina. So this is the case of nearby objects. This is the case of the myopic eye with distant object. What are the reasons for this defect? The first reason is the curvature of the cornea and the eye lens increases. And the second reason is the eyeball elongates so that the distance between the lens and the retina increases. Now reasons you have found out. How to correct this defect by using what? That we are going to study now. Now this defect, it can be corrected by using spectacles with concave lens of proper focal length. Remember this topics very clearly, slight confusion can be there. So myopia, concave lens, ahead you will study about hypermetropia, then it will be convex lens. So it can be corrected. If you use the word cured, you will lose the marks. The defect can be corrected by using the spectacles, because once you keep the spectacles aside, then the same thing of the looking at the objects becomes the image of the objects, they become blurred. So this defect can be corrected. Use the word properly. What happens with the help of concave lens? What is the property of concave lens which you have studied? That concave lens is a divergent lens. Concave lens is a divergent lens. So this lens, it diverges. Now you can see the placement of concave lens. It diverges. The light rays are moving apart, spreading. So they diverges the incident rays, and this diverged rays can be further converged by the lens in the eye. The lens in our eye is convex lens. They can be converged with the help of this lens in the eye to form the image of the far object on the retina. The focal length of concave lens is negative. So a lens with negative power is required for correcting nearsightedness. You have heard about the spectacle numbers in our day-to-day life. Some say my number is negative, some say we have positive number. So today you have come to learn one more thing, that it depends upon the type of lens which is present in their spectacles. The power of the lens, it is different for different eyes depending on the magnitude, their intensity of the defect. Our next defect is exactly opposite to myopia. It is known as farsightedness or hypermetropia. There it was nearsightedness or myopia. Again, this word itself tells you that faraway objects, the human eye can see faraway objects clearly but cannot see the nearby objects distinctly. There, the image of the faraway object was formed in front of the retina. Here, the image of the nearby objects, you can see it is formed behind the retina. The next is reasons which we have studied for myopia. Now the reasons for farsightedness. In that case, the curvature of the cornea and the eye lens was increasing. Here, in the case of hypermetropia, it decreases so that the converging power of the lens becomes less. There, the converging power of the lens, it remains large. So when you are studying the reasons, when you are studying about the defects, you have to study in comparison. Then the learning part will be easier for you. Due to the flattening of the eyeball, there the eyeball was elongated. Here the eyeball is flattening. The distance between the lens and the retina decreases. There it was increases. So now which type of spectacles? This defect can be corrected by using a convex lens. There it was a concave lens. What does the convex lens do? You know that the convex lens is a converging lens. So this convex lens which is used, it converges the incident light rays before they reach the lens, and the lens which is there in the human eye, it further converges this rays and forms the image on the retina. The focal length of a convex lens is positive. Thus the spectacles which is used to correct farsightedness has positive power. Next is the third type of defect, presbyopia. This is mostly known as the old age hypermetropia. Here what happens, the focusing power of the eye lens, it decreases with age. You might have heard that old aged people, they are not able to see the objects very clearly. The muscles, the ciliary muscles which hold the lens, they lose their ability to change the focal length of the lens. You have studied about the power of accommodation, the capacity of the lens to change the focal length. So as the muscles become very loose due to the age, they lose their ability to change the focal length, as a result of which the old people, they cannot even see the nearby objects clearly. Sometimes these people, they suffer from nearsightedness as well as farsightedness, and in such a case, which type of spectacles, which type of lenses is used? Bifocal lenses are used. In such lenses, the upper part of the spectacles is a concave lens and it corrects nearsightedness, while the lower part is a convex lens which corrects farsightedness. Photograph is not given in the textbook. I have taken one of the images from the net. This is the normal eye. This is the presbyopia, and here it is the presbyopia which is corrected. You can see the image behind the retina. Hence it is mostly called as old age hypermetropia. You know, old age in hypermetropia, the image is formed behind the retina, and in the third case you can see that presbyopia is corrected. So image on the retina. With this we complete our very important topic. Now the types of questions which you can expect on this topic is in different ways. Just we will go to one of our previous slides. Here you can see the different diagrams are there in the textbook also. So a diagram can be given to you and you have to identify which type of defect is being faced by the human eye. So if such a type of diagram is given, then you will answer that the eye, the person is suffering from hypermetropia, and then they will ask what they define that particular defect and where is the image formed, what are the reasons for the defect and how it can be corrected, and also draw the corrected diagram. So corrected diagram means this by using convex lens. Accordingly, they will ask for myopia. This is the question, one way it can be asked. Second way is distinguish between myopia or hypermetropia, and third can be a direct question for 5 marks. Define myopia. Where is the image of the distant object formed in case of myopia? What are the reasons for this defect? How it can be cured? And what is the power of spectacles for a myopic eye or hypermetropic eye? So whatever questions I have told for myopia, same they can ask for hypermetropia. And presbyopia also, direct question can be asked. So this 3 topics, prepare it thoroughly in all the ways, along with diagrams, along with the corrections. The diagram which is the corrected diagram after that particular defect by using that particular type of lens. Now our next topic is very important, uses of concave and convex lens in our day-to-day life. So the first we will take up is use of concave lenses. It is used in medical equipments like scanner, CD player. These instruments, they make use of laser light, and for proper working of these equipments, concave lenses are used. Scanner, CD players are the things which are known to you. This is you can say application in our day-to-day life, safety, you can say device, small device, the peephole in the door which all the people who stay in the building they have. This is a small safety device which helps us to see a large area outside the door, which makes use of one or more concave lenses. Third is, you all know spectacles, just now you have studied. Concave lenses are used to correct nearsightedness in torches. Concave lens is used to spread widely the light, divergent lens. So from the source the light rays are diverged. So in the dark, when you use a torch, the light rays from the source, that is the torch, they are diverged and cover a larger area, due to which you can see in the darkness. Camera, telescope, microscope. Now if you see the main part here, these instruments, they mainly make use of convex lenses. But to get good quality images, a concave lens is used in front of the eyepiece or even inside it. So these are the different uses of concave lenses. A direct question can be asked over here. The next is use of convex lenses. The first use is simple microscope. The second use is compound microscope. Third, telescope. That part they have removed out from the syllabus. And the fourth is optical instruments. Let us see the first use, simple microscope. Now here a convex lens. Now we are studying about the convex lens uses. With small focal length, it produces a virtual, erect and bigger image of an object, due to which such a type of lens is called as magnifying lens. Why? Because if you have to visualize something, then one can get a 20 times larger image of an object using such microscopes. And hence this type of microscope is used by watch repairers. You have seen that watch repairers, when they are repairing the watches, they see through something that is nothing but convex lens. So the small parts of the watch which cannot be seen by the normal eye can be magnified and seen with the help of this lens, and they can be repaired properly. Similarly for testing precious gems, finding their defects, etc. Next is compound microscope, which is made up of two convex lenses. One is the objective and the eyepiece. Both these words are not new to you in the 9th standard. In the last chapter, observing space with the help of telescopes, in optical telescopes we have studied about objective and eyepiece. Here simple microscope, just now which we have studied, it is used to observe only small sized objects, but very minute objects like pure blood cells, cells of the plants and animals, minute living beings like bacteria, they cannot be magnified sufficiently with the help of simple microscope, and their compound microscopes are used. So the microscope which is used in the lab is a compound microscope. Now here the objective lens, it has smaller cross section and smaller focal length, whereas the eyepiece, it has bigger cross section and its focal length is also larger. See, this is the objective lens, this is the eyepiece. Its focal length is larger than that of the objective, and higher magnification can be obtained by the combined effect of these two lenses. how it works. The axis or the image, you can say, magnification here can be seen in two stages. The image formed by the first lens, that is the objective, it acts as the object for the second lens. The axis of both the lens are along the same line and the lenses are fitted inside a metallic tube in such a way that the distance between them can be changed. This is about the compound microscope. Here also direct question can be asked or a diagram can be placed ahead of you in the question paper. You have to identify and describe that microscope. And the last use is optical instruments. Now this convex lens, they are used in different optical instruments. Optical, like camera, projector, spectrographs, etc. Whatever photographs I could get from the net, I have placed here ahead of you. Apart from this is an open-ended topic, uses of concave and convex lenses. Search through the Google net, you will get n number of other uses of concave and convex lens. In the exam also, if this particular question is asked, you can write uses of your own by making use of different social media. The name of our subject is Science and Technology. Use the technology, different types of technologies like mobile phones or Google Net from the mobile phones, and find out various uses of these lenses, and that also you can write in the exam. With this, we wind up with our today's session. Now the small topics which are left from this chapter are persistence of vision and about the light sensitive cells which are present in the retina. That we will take up in our next session. Along with that, I am going to discuss the textual questions and the additional questions for this chapter. In our next session, I will be completing the discussion of textual questions. I will be completing the additional questions, and if time permits, I will take up the textual and the solved examples for this chapter. So be present for the next session with a textbooks along with you. Thank you, dear children.